probably be done here is that it's probably going to require that this window be temporarily removed.
Okay.
That these joists here that bear above the window be temporarily, oh gosh, it's going to be a bit of a tricky job now that I think about it. There's a number of ways you can do it, but probably the least expensive way is to temporarily support this floor structure. Now bear in mind this floor, this band beam here, and the ends of these joists have a wall sitting on them, and the wall supports the roof. So there's a substantial amount of weight that comes down across here. So if the window were taken out, these joists need to be temporarily supported in a way that will hold up not only the joists, but indeed the wall and the roof above. That's all possible, but it takes some doing. Then I would say in this case, at least as far as the structural repairs are concerned, probably the easiest way to fix this is to put a beam under here, under these joists and under the band board, and to put a column here at the jamb location and another column over there to hold up that beam. And then put in a new smaller window. That is an option. I'm not saying that that's a perfect option. It obviously leaves you with a smaller window. I'm just saying that it is a structurally acceptable approach. There's another way to do it, which is hard to do but possible, and that is to temporarily support the structure above and to cut these, to take out this band board, cut off the ends of each of these floor joists about, let's just call it now, 2 inches from the current end of the joist, and then you stick a beam up in there, roughly in the location, a wood beam, roughly in the location of the current band board, and hook the floor joist to that beam with new hangers, and that beam would bear over here on this side, and it would bear over here on this side.
And then the window would stay. This window.
And the window would stay. So that's another option.
It's also on this window the home inspector noticed because he couldn't open or close it because of the bowing of the top there.
Yeah, exactly. So some sort of similar repair could be done here. And if one wanted to retain the window of this size, one could lower the window. It's not that hard to take out masonry down, let's just say 1 foot or 8 inches or whatever, and put in the window at a lower level and put in a beam under there. Otherwise, you could do the repair in a similar manner to what I just described over there, where you cut these joists and temporarily support stuff and so on.
If nothing was done, what would happen?
Well,
so what's the underlying issue?
Okay, so I haven't done any calculations yet, but you know, to give absolutely black and white determination of where we're at in terms of the strength of this structure, but my judgment based on experience with these things is that this 2x10 here, which is basically holding up the floor joists, is not strong enough for the opening. And
if it's been that way for a long time, what are we looking at? What damage is it going to do in the next year or two? Or, in other words, is this something that the sellers need to fix to sell their house? That's the question. Is there imminent damage? Is there imminent danger?
I would, again, I would have to do calculations to make a rigorous determination of where we're at.
Okay.
But basically, if you were to have a congregation in this house, like a big party or something, and or somebody just storing a lot of goods, and you were to load the floor up to 40 pound per square foot load level, which is prescribed in the applicable building code, then and again, I would have to do this, I'd have to do calculations to verify this, but I am inclined to believe at this time that this beam here is undersized and the structure would be unsafe under those conditions. And so a structure can stand for a gazillion years without collapsing. It's just that when you finally have that great big congregation, that's when it decides to.
So it's a safety issue at this point?
Yeah. And again, I do need to do numbers I do need to crunch some numbers to absolutely verify that that is the case.
Could you do, you'll do that?
I absolutely will.
Thank you.
Yeah.
Okay, are there any other things that you can kind of spot down here as like, you know, with that crack right under the window, or is that just a settlement because it's vertical?
Yeah, I think that this is probably a combination of two things. I think it's mostly a crack that has resulted from shrinkage of the block. The block shrinks over its life because of basically three sources. One is it absorbs carbon dioxide from the air and undergoes chemical changes which causes it to shrink. Two, it dries over its life. And three, in the wintertime anyway, there are temperature changes which shrink the above grade portion of the wall. The below grade portion of the wall keeps warmer because it's below grade. And so that also tends to cause shrinkage. And that shrinkage, all three of those forces tend to act more on the above grade and exposed part of the wall than they do on the below grade part of the wall. And hence it is common to find cracks, vertical cracks in concrete wall or concrete block walls, which are wider at the top than they are at the bottom.
Okay.
And this one here is less than 1 millimeter wide down there near the floor, where it ends about 4 inches above the floor. And up here it's maybe, I'll say that it's, I don't know, 3 or so millimeters wide. It's noticeably wider at the top than at the bottom. So it tends to follow that pattern. None of those factors are structurally significant.
Okay.
Yeah. So let me just check one more thing. How plumb the wall is. The wall here is pretty plumb. I'm getting the bubbles between the lines. So this wall is plumb. An out of plumb wall is generally more of a concern than a wall with a vertical crack in it.
Gotcha.
This wall looks like it's in okay shape. And I would imagine the same thing is true over here. You've just got a pretty long stretch of wall, and you had a vertical crack here. You don't even have any retained soil on the opposite side, so there's no issue with earth pressure pushing the wall in the way you have over there. Mm-hmm. So I do not consider this crack here to be structurally significant. I think it's a perfectly acceptable approach to dealing with that crack is to do nothing with it.
Okay.
You know, that's not significant.
Anything else? Maybe in this portion of the basement, or are we talking the same treatment since it's the front wall?
Okay, well, over here I've put the level on, and first of all, I'm not seeing any horizontal cracking or any cracking in the horizontal mortar joints. So that's the telltale sign that the wall again has buckled inward, as I was describing earlier. And I'm putting the level on the wall, and this indicates that the wall is plumb in this location.
Okay.
So the out of plumb condition, let's just see, it seems to be, well, we've got this horizontal crack extending over to about, gosh, I guess about right here. Now let me see. I mean, even here the wall is plumb. So it's not quite plumb, but it's maybe 1/8 of an inch and 2 feet out of plumb here, right here at the bottom of the stairs. That's for a 12-inch thick wall. That's just not much.
Okay.
You know. Now, I want to say that if the wall should continue to buckle inward, then structural repairs would be required to it. And and maybe they will be someday, but I think that will be years or even decades into the future. And it would likely it's probably true that the most cost-effective repair would be the installation of carbon fiber strips. There would be a little engineering work to determine that that is the most cost-effective and feasible way of fixing this, but that would have to be some sort of a repair like that would have to be done, and for a stretch of wall like this, about I'm estimating visually, I'm going to call this 24 feet. That's 7 carbon fiber strips. That's probably about a $5,000, maybe $6,000 repair job.
Okay, so you wouldn't have to put carbon fiber strips all around the basement. It would just be for really this section of the wall from this little wood board area down to the corner here, right?
Yes, right.
Okay.
From about where I'm standing. But let me check. I haven't checked this area over here yet.
Okay.
I don't think there's a problem here because I'm not seeing any evidence of cracking. The wall is plumb there. Again, I'm not seeing any horizontal cracks. We've got a vertical crack here. I don't believe that that's structurally significant for the same reason that I don't believe that that one over there is structurally significant. The wall is plumb here. As we get over here, the grade is getting lower and lower. That means the stress on the wall gets less and less as you go that way.
Okay.
And the wall is plumb here. So I think this right foundation wall, right being as one faces the house from the front, I believe that right foundation wall is showing no signs of structural problems at this time.
Okay, can you talk to me a little bit about the effectiveness of carbon fiber strips? My client was a little worried that it's not really strong enough.
Well, I'll tell you what. Okay, carbon fiber strips, it's a technology that's been used now for, I would say, widely used for at least I would say for at least 15 years.
Okay.
Now, excuse me, municipalities require that they be tested for effectiveness by a certain testing agency, and testing agencies provide reports to claim their validity. Right now, to my knowledge, there are no companies that can provide such reports, despite the track record of this technology being used on commercial structures. So that said, there is, however, there are companies that are getting that testing done, and that testing is likely to be available in the near future. If that fails, and carbon fiber strips cannot be used, then there is an alternative and well-established method of repairing walls like this, which is to install steel beams vertically spaced about 4 feet apart along the length of the wall. Those are embedded in the floor. They get attached to the ceiling structure, and they are put up against the wall, and they prevent the wall from buckling further.
Kind of like studs.
Kind of like studs.
Okay.
Kind of like studs. And so that is an acceptable and acceptable from municipalities' points of view that approve these plans when they're giving out building permits.
Okay.
It's an acceptable method of repairing damaged foundation walls. I don't think I've designed a job like that for Montgomery County and had them pass or fail a design based on that. But I have done projects with that type of repair, designed those projects, and submitted them to Fairfax County, a number of them, and they have been approved by Fairfax County.
Okay, so if this were your house, would you put in carbon fiber strips, or?
Right now, no. What I would do is I would keep an eye on the wall and take action only when the wall moves. It is a distinct possibility that this wall will not move at all in the next 10 years.
Okay.
And it's